Good morning, sir. We are Group 11. Our group name is the 202 network. We're gonna present our network assignment for today. My name is Iba Muhammad Abbas Ahmed, and I am the leader. And member 2 is Lama, and member 3 is Siti Zuleika, and our member 4 is Mu Yonjin. Next, our IP addressing. So we base our ID addressing based on our birth date. So the formula, we had two formulas for the IPv4 and the IPv6. For the IPv4, it was 202 dot our date and dot our month dot from 0 until any number. And then for the IPv6, the formula was 201 dot db8 dot two letters of our two numbers of our day, and then month, and then year. So we did it for the whole 4 members, for Iba, Lama, Zuleika, and Mo. And then after it, this is our final project overview. This is our final project overview. We follow all the standards and all the areas. So we're gonna start first by explaining. So by explaining the purple area and the yellow area, which is the core network, and the dual stack service network, which was done by me. So for me as member 1, what did I do? First, I start with the core network. I set all the 6 switches and I enable it. I enable the CTP. And then I worked on the purple area, which was a dual stack service. I add all the services, the DNS, email, FTP, and dual, and set them all based on my IP and IPv4 and IPv6. And then I added a new network only for the web service because it was I added a new network only for web service because it's the only one from the services is connecting it immediately to router 1. So that's why it had another IP, which is instead of 12, is 13. Next, my yellow area and purple area, I enable the high availability. I add the 6 switches, and the features I have is the spanning tree protocol, and the A02.1Q trunk link, and the overall topology. So when I make it, I made sure that it follow all the standards you made in our assignment question. So next is my web server challenge. So my challenge was that I required to connect the web service to router 1 through FA000 with the cross cable. The problem is the FA000 is a switch port, so it cannot route. But also at the same time, I already use my gig 02 and 00. So I only had an option to work with it. Yeah, since the routers only have 2. So the solution I came with is to set an IPv4 and IPv6 and configure it with VLAN 1 and this web server. And then I add the OSPF to the full network connection. And as you can see, here's the final view, and they all can work. I'm going to show it later in the live testing. Next is the security. In the security, I worked on the router 1. I added all the OSPF, and I add the password and the console, the SSH, ACLs, and I also add a banner message. For the switches, I add the security to switch 1, switch 3, and 4, 5, and 11 with this formula, while X representing the switch number. So I made sure to follow all the bonus mark for security. Next, I will pass the mic to Lama.
Hello everyone, my name is Lama and I will be responsible for configuring network 1, which is the IPv4 user network, along with router 2, which is the pink area. Let me explain how routing works across our entire network. All of our routers in our project use OSPF, which stands for Open Shortest Path First, for dynamic routing between networks. Now you might ask, why did we choose OSPF instead of just using static routes? There are 3 reasons. First, OSPF is automatic. If any link in the network fails, OSPF immediately recalculates the best path and find an alternative route, no manual intervention needed later on. And secondly, it's scalable. As our network grows and we add more routers or networks, OSPF handles everything automatically without requiring manual updates to every device. And third, it's an industry standard. Most real enterprise companies use OSPF in production network. So learning it prepares us for the real world. Now, if you look at this screenshot, you can see router 1, router 2, and router 3 have all established full neighbor relationships. This full state means they are successfully exchanging routers information with each other. So because of OSPF, router 2 automatically knows how to reach EBA's server network and Zuleika's IPv6 network and even Mo's wireless network, all learned dynamically without any manual configuration. Next slide. Next one, 11. So moving to DHCP configuration for network 1, I configured router 2 to act as a DHCP server, which means it automatically assigns IP addresses to users when they connect. Here how it works in practice. When any IPv4 user like a laptop or PC connects to network 1, they automatically receive three important things. First, an IP address from our pool ranging from 202.3.10.10 all the way to 202.3.10.100. That gives us space for up to 90 users. Second, the default gateway, which is 202.3.10.1, that's router 2 itself. This allows users to communicate with each other with other networks. And third, the DNS server address, which is 202.10.12.10. That is DNS servers. This lets users type web.company.com instead of remembering the IP address. The beauty of DHCP is that users don't need to configure anything manually. They just plug in and connect. This eliminates human errors and saves a lot of time, especially in large networks. As you can see in the screenshot, we currently have 4 active clients who successfully received their configuration and are communicating with all the servers without any issues. Okay, next slide. Okay, finally, let me talk about high availability and how we prevent network loops. In our core network, we have 6 switches with multiple connections between them. While this provides redundancy, it also creates risk of switching loops, which can crush the entire network in seconds. That's why spanning tree protocol or STB comes in. We configured core switch 1 as the root bridge with priority 4096, which is the lowest priority. This makes it the boss of the spanning tree. Core switch 2 is configured as the backup route with priority 8192. If core switch 1 fails, switch 2 automatically takes over. Now, if you look at this diagram, the red links you can see are in blocking state. These are our backup path. So they are ready, but not actively forwarding traffic right now. So here's the important part. If the primary path fails, let's say a cable gets cut or a switch goes down, STB automatically unblocks these backup lines within a few seconds and traffic continues flowing with minimal disruption. So we actually tested this during our troubleshooting. We disconnected one of the core switches and the network kept working perfectly. That's what we call true high availability. This type of redundancy is critical in real enterprise networks where downtime costs money. So next slide. Okay, security slide. For network security in the IPv4 user network, I implemented multiple layers of protection. On router 2, I configured SSH version 2 with RSA encryption for security remote management. All passwords are protected with enable secret console and VTY line passwords. Both access switches, switch 21 and switch 22, have encrypted passwords using the server's password encryption command. And each switch has unique enable secret password following the format secure at SW2X #2026 for wireless security. And the access point uses WPA2/PSK with AES encryption. The SSID is company IPv with a secure passphrase. Finally, the DHCP server provides automatic path control IP assignment, distributing only to the assigned range 202.3.10.10 through the 100. With the proper gateway and DNS configuration, this multi-layer approach ensures that even if one security mechanism fails, others remain in place to protect the network. Next slide. Okay, now I will pass the presentation to Zuleika, who will explain the IPv6 network was configured. Thank you.
Okay. Hi, my name is Zuleika. Next slide, please. I was responsible for the IPv6 user network in the Cyan area. This network demonstrates a pure IPv6 implementation with router tree as the gateway, DHCP v6 for automatic addressing, and a redundant switch design. Next, please. Router tree has 3 interfaces configured, which are Gigabit Internet 00, access the IPv6 gateway, Gigabit Internet 01, connects to the core network using dual stack, and Gigabit Internet 02 connects to router 2 using IPv6 NIC local addressing. Next, please. For routing, OSPF-v3 is configured with router ID 3.3.3.3. Router 3 forms OSPF agencies with router 1 and router 2, and a static route is added as a backup for redundancy. Next, please. At the access layer, switch 31 and switch 32 are used with an interswitch linked on fast Ethernet 024 to ensure high availability and network reliability. Next please. So for the DHCP V6 connectivity, so IPv6 addresses are automatically assigned using DHCP V6 as shown on BC31 and BC32. And I've already added like some screenshots on how it was configured. And all IPv6 connectivity tests were successful with 0 packet loss. Next please. For the router security enhancement, there were some security enhancements made on router tree, including an enable secret password set to class 123, a console password Cisco 123, and SSH enable using the admin account with password admin 123, and IPv6 access control list to improve network security. And next. And lastly, both switch 31 and 32 are also secured using enable secret and console passwords. So SSH is enabled for secure remote management and TEL is disabled to prevent insecure access. So in conclusion, the IPv6 user network is functional, secure, and scalable with successful routing, addressing, and security configurations. So I will be passing my mic to Mo. Thank you.
Hello, my name is Mo, and I'll be talking about the wireless network. Next slide, please. So for the wireless network, it has containing 3 individual access point with the individual Wi-Fi passcode that is holding the WPA PSK passcode by the radius system, the marketing, which is the password of the marketing at 123, the engineering at 123 is the password, and I guess. And for this, I'm using also a AAA system for the radius system server to make sure that the users need to log in before connecting to a server. And for enhancing the router, I'm using for SSH. The username is for the admin, and the secret password for it is actually for enable at 13. And as you can see, the screenshot down there is actually showing the router and the switch are actually connecting to the server successfully. Next slide, please. So to ensure that every laptop is connecting to a server and connecting to each other, so I'm using the SSH clients to test whether it can ping to the server or not. So as you can see the screenshot there, when I ping the server 202.2.6.1, and it shows like success rate. And when I'm using the command prompt also, it actually shows success. And they actually gain the IP automatically from the server itself for the IPv4 and IPv6 address. And that's all for me. Thank you.
Okay, thank you, Mo. Okay, and with the most important part is end-to-end testing. For end-to-end testing, we did all the testing and put the screenshot on our report. So I'm gonna go through it quickly. Okay, so the first test we did, it was to test the IPv4 from PC to a web server. So we did this test on the PC1, on the Llama network, the pink one, the pink area with the purple area, to check if they connect together. So one PC and with the router. And after we did it, we guessed successfully. Here we pinned 202.10.12.20. We pinned the web server, not the web server. We pinned the email server, and it was working. Next, we have the IPv6 testing. So for the IPv6, we did it from a BC to ETP. So it's the same areas from Llama part, the pink area, the same BC with the ETP server. And also the same, we get success, 0 loss. And then we did test 3 on the DHCP v4 on router 2. And also it's fully functional. And then we did the TNS, the test 4, to make sure it works. And we get it delivered, and when we bin it, it's also 0% loss. And then for the web server, when we did the test, so yeah, in the PC1, same PC in the yellow, the pink area, and get the website loading successfully. Next, test 6 is about the radios, which is in the wireless network, which is the green area. And we also get it all success. And then the last and not least, that is 7 about the OSPF neighborhood. All the switches, we got them to be neighborhood together, so they with using the OSPF. So everything is running successfully. And I want to do a live testing with you, just a small one. So I'm gonna open the router one. So this is one of my features in router one. When you open router one, you can see a banner. And then after you put the password, write enable. And then our second password. So right now we are inside router one. So from router one, I'm gonna try to pin router two. Which is 10. Yeah, 10.0.0.2. Okay, I think it's all success, 100%. And then the next thing I want to test with you is to pin it to one of my servers. So I'm gonna use as you can see here in this table, we list all the IPs. So everything is organized. So right now I'm gonna pin the email 202.10.12.30. Okay, also as you can see, it's 80% successful. Okay, but we can do a lot more of tests to provide our to make sure like our bucket is working. But for now, because of the time limit, we provide the screenshot, everything in the report. And then for the last thing for today, okay, so last thing, what we learned. After we finish all the big assignment, we learned a hands-on on network, building a real networks. And it was experience using the Packet Tracer. Next, we documentation, simplified reports, and then the frequent testing save time. And of course, the teamwork is essential. And our final network summary, we have successfully implemented all the requirement component and also all the bonus feature. And thank you.